We're going to talk about now superposition if you have three particles that are not in a straight line. The example we looked at before was for three particles in a straight line. For this example, we're going to look at three particles that are in the shape of a triangle. So the first thing I want to do is, this is a right triangle. I want to find the angle here with respect to particle number 3. In our question it says find the magnitude and direction of the resultant force on Q3. So I need to know the angle of Q3 right here with respect to particles number 1 and number 2. So to do that, I'm going to take the inverse tangent of the opposite over the adjacent side, so 3 over 4, and you get 36.9 degrees. Make sure your calculator is in degree mode, not radian mode. Next I'm going to go through and I'm going to find the force on Q3 because of charge number 1 and charge number 2. So in order to find the force between particle 1 and particle 3, 1 and 3, I need the distance between the two particles. The distance between 1 and 3 is 5 meters. So I'm going to take Q1 times Q3 divided by 5 squared and multiply that by K. Now I'm going to look at the force between Q2 and Q3. So to do that, I'm going to take the charge of Q2 times the charge on Q3 and divide that by the distance between the two particles, which is 4. Don't forget to square 4. So I'm going to speed up just a little bit here. I'm going to plug in my numbers for the force between Q1 and Q3. So I go ahead and plug those in. I plug in charge for charge number 1, charge number 3 divided by 5 squared times 8.99 times 10 to the 9. And then I get this answer, 1.26 times 10 to the negative 8. Fast forward a little bit more. Try and go a little faster for you. So then what I'm going to do is I'm going to calculate the force between Q2 and Q3. All right, plug those in. All right, so I've got 8.99 times 10 to the 9 times negative 3 times 10 to the negative 9 times 5 times 10 to the negative 9, all divided by 4 squared. Plug that in your calculator. Make sure that you put everything in correct scientific notation. You should get negative 8.43. That negative tells me that this is an attractive force. I have a negative charge and a positive charge. Opposites are going to attract, so that means that particle number 2 is attracted to particle number 3. The first force is repulsive, so the force between particle 1 and particle 3 is actually pushing Q3 away. But 2 is attracting Q3, so you're going to have a force that's pointing to the left, toward particle number 2. So your free body diagram is going to look something like this. You're going to have a force coming off at an angle. This angle is opposite interior, so this is 36.9. That means this angle right here is going to be 36.9. So we're going to draw our free body diagram. There's our charge, here's our force 1, 3, here's our force 2, 3, and there's our angle. We're going to use this free body diagram in the next video, which I'm going to pull up for you right now. We're going to use that free body diagram to calculate the force in the x direction and the y direction. That should sound familiar because we did it a lot last semester when we were adding force vectors with free body diagrams. So here's our free body diagram again. The force between 2 and 3 is attractive, so it's going to point toward charge number 2. The force between charge 1 and charge 3 is repulsive, so it's going to point away from charge number 1. So we can draw that. Move ahead just a little bit. Zoomed in for you. There we go. So now we're going to have to break this vector up into its components. So I'm going to break it up into its x component, f13x, and into its y component, f13y. So I'm going to calculate f13y by taking f13 1.26 times 10 to the negative 8. I'm going to multiply that by the sine of 36.9 because y is opposite of the angle. Opposite over hypotenuse is going to give you the sine. So in order to find the value for this side, I need to take the sine of 36.9. You're going to get negative 7.57 times 10 to the negative 9. Sorry that that is so yellow. I'll fix that next time. Then I'm going to take it, I'm going to find f13x. X is adjacent to my angle, so I'm going to use cosine to calculate the value for the x component of this particular vector. So 1.26 times 10 to the negative 8 times the cosine of 36.9, that's going to equal 1.01 times 10 to the negative 8 newtons. So now what I'm going to do is I'm going to go ahead and break up the other vector. Because it's only in the x direction, it does not have a y component. All of the value, all of the magnitude of that vector, okay, is going to act in the negative x direction, okay, because it's pointing to the left, so it gets a negative sign. So we don't have a y component because that vector only points to the left, okay, it doesn't have an angle, it's not going up and down, it's only going to the left. So if you remember from last semester, we talked about how to add vectors in the x and y direction. We take and we add all of our x components together, we add all of our y components together, and we find the sum of the forces in the x and the sum of the forces in the y. All right, so that's what we're going to do next. We're going to find the sum of the x and the y. So I'm going to take my first force in the x direction, f13x, and I'm going to take my second force in the x direction and add those together. 1.67 times 10 to the negative 9 is what you get. I only have one y component. All right, I do not have a y for force 2, 3. So I only have a y for force 1, 3. So when I add those together, I get negative 7.57 times 10 to the negative 9. We plug those two numbers in the Pythagorean theorem. All right, so my formula is F net squared equals the sum of the forces in the y squared plus the sum of the forces in the x squared. So when I take my two forces that I just found, I want to take the square root because I need to get rid of the squared here. So I take the square root of the entire right-hand side. 1.67 times 10 to the negative 9. Don't forget to square that. Plus negative 7.57 times 10 to the negative 9. Make sure you square that as well. Add those together, take the square root, and you have found your net force. A little bit more involved than when you have charges in a straight line. When you have charges in a straight line, you can just either add or subtract based on the direction that the vector points. But when you have charges that are in two dimensions, the x and the y, you have to break them up into your x and y components. Find all of the components that act horizontally, your x direction. Find all of the components that act vertically. Add those together, plug them in the Pythagorean theorem. We're going to review the direction whenever I come back from break. I hope you have a great spring break. Have fun and be safe.